So find the limit of the difference of these two functions. And first of all, you see that when x approaches 0, right? This is kind of like a positive infinity minus infinity type. So you cannot determine the derivative, the limit directly. Maybe the gap, the both terms approaches infinity. Maybe the gap between them is getting close, small. Okay. So how do you do that? You have to modify the function, combine them into a one fraction. So you get x minus 1 minus x. So now you will see that it is going to be, I think, a 0 over 0 type. Okay, then you apply the L'Hopital's rule. Okay, you differentiate. It's a little bit more complicated. So when you differentiate the denominator, it's going to be e to the x minus 1. Then you differentiate the second part, just x times e to the x. Okay. The numerator, e to the x minus 1. But when you plug 0, every time before applying the L'Hopital's rule, you have to double check. Okay. It's going to be 0 over 0 type again. Plug 0 for x. Okay. So you get 0 over 0. So you continue and differentiate the numerator and denominator. So you get e to the x. And here's e to the x. The derivative of x times e to the x will be e to the x plus x times e to the x. Okay. So now this is not going to be 0 over 0 type, because when you plug 0 for x, you get a 1 in the numerator. But the denominator also not going to be 0. So it's going to be 1 over 1 plus 1. That's 2, 1/2. Right? So we are done with the problem. Right? The answer is 1 over 2. Right. Today's section is about integration by parts. We're going to learn some methods to evaluate the integral. Okay. The integral and the derivatives, integral and the differential, that they are opposite to each other. Okay, so this is called differential. It's hard to understand this concept. It's differential of the variable x. Okay, it is another variable, but use 2 letters to denote them, but associate with x in some way. It's coming from x. So if there's no x there, you cannot talk about dx. If there's x there, you can talk about differential. It's kind of a small change in the x variable, another independent variable, but it's good. Another variable, okay? It's not independent, another variable. And it's called dx. Okay, got it? That's odd. So if x depends on another variable, if x depends on another variable t, okay? For example, x equals f of t, right? It's not necessary to write down in this form, but just x depends. Then you have a dx, you have a dt, right? Because both are variables, so they can talk about differentials of the variable. Then they are related to by this formula, right? This is about differential. I just have a quick review. So the differential of x and the differential t are related by this. So this is a dx. As I said, that integral and the derivatives, they are a differential, they are opposite to each other. Okay, so we have an integral, right? The very important form is a trivial formula. is this. Okay? The integral of 1 as a constant 1 is going to be x plus constant. Oh, that's true. Everybody knows that. Okay. So this is a formula. Okay. This is I call the fundamental formula of calculus. Okay. So in other words, I put the integral symbol. The symbol on the left hand side is just a stretch of the s. S means initial of the sum. Okay. So integral usually means sum. Okay. Add them together. Okay. Differential means kind of an instant rate of change. But this is the important formula. It's a trivial formula, but everything comes from there. Just like our life, coming from cells. Okay, this is the original formula. It's trivial, simple formula. Okay, everybody knows that. Anyone who took calculus knows this formula. Okay. So I'm going to change this a little bit. How about how about x equals f of t, right? I know dx is going to be f prime t dt. So I put that. So integral, what is dx? F prime t dt. What is x? F of t plus c. That's the formula. Okay? Right? I can express this formula in a slightly different way. Okay? So if f prime t equals g of t, okay? That means f prime t is the antiderivative of g of t, i.e. f prime t is an antiderivative of g of t. The above formula can be written in the following form: g of t dt equals f prime t plus c, right? Got it? It's the same. And here I don't need to say anything. Here I have to say g of t is the antiderivative f of t. Okay, so this is a formula we're familiar with. That. We learned that in Math 166, calculus 1. Where it's from? It's from this trivial formula. Okay, now I tell you, right? So you have a little bit more complicated formula, and then you have this one, another version of that formula. Okay, now I have two variables. I have two variables, u and v. I don't know how that depend on another variable. Okay. What is this? Yeah. So given two variables, you can talk about the derivatives. You can, then u times v, it's product of variables. Okay. So this can be a new variable. By the product rule, the differential of these two variables is going to be the differential of this first variable times v, and it's called, this is a product rule, okay? It is product rule. This is a product rule. Okay. Maybe u or v depend on another variable. Okay, at this moment we don't care. Okay, but u times v gives a new variable, and I simply still denote by uv. Okay, uv you can think about uv is just a combined names. Okay, use the two letters to denote the product, and the product rule says that duv. We have to they must satisfy certain rules. Yeah, so this is going to be that. Okay. I can also switch the order, says v du, doesn't matter, that's a product, right? Okay, I can simply write this. Okay, I'm going to put the integral on both sides. Then what do we get? This side I got UV, right? A plus constant, let's call C1, right? Yeah, let's just plus C. Okay, on the right hand side I have two terms. Okay, so this means integral of u dv is going to be uv, okay? And I move this to the other side. Now I don't need to put a constant here because the indefinite integral has another constant there inside, okay? So you have this identity, right? Coming from here, from above. That's called integration by parts. You can also think about that uv is going to be duv minus vdu, okay? The matter is the same. And you put the integral there on both sides directly, and you get the above formula, okay? That's it. So where's it from? They come from the original formula. So where is this from? This is the origin of the life, okay? That's it. They all come from here. Okay, so this is a useful formula. Got it? Okay. All right, I'm going to apply this formula to solve a problem. Okay, when you write the integral, don't drop the dx part, okay, or dy. It's very important. It's a part of the integral. Now you realize that's important, okay? So something when they integrate the function, just keep writing and trying to save time and forgot dx or dy. That's wrong, okay? So you cannot skip that. Okay? It's very important, crucial here. What is variable we're talking about? du, dv, right? All right, so let's look at the following problem. Okay, I'm going to, we know that, right? We suppose, yeah, we know natural log is a very important function, right? But very simple question: what is the antiderivative of natural log of x? What is, right? In other words, what is the integral of this? We don't know. We already know the antiderivative of many famous important functions. So when we deal with this, I find it's difficult, right? All right. So what I'm going to do is I can apply the integration by parts formula. So I call this u, okay, and then x is v. Then according to the above formula, I can say uv, right? Natural log of x times v x minus x v is x, and the d natural log of x. Okay. So that is going to be x times natural log of x minus x. What is the d natural log of x? D natural log of x, just du, right? Which is going to be 1 over x dx. Okay. Then it's easy to solve the problem. And this is just a one-to-one. It's x natural log of x minus x. Don't forget for the constant there. So that's it. Okay, here u represents natural log of x. So d natural log of x means du. Okay, so u equals natural log of x, du equals, right, d natural log of x. You can write it in this form. This is going to be du over dx, dx. And that is going to be 1 over x dx. Okay. Then if I have this, how can I do that? Right? I want to get rid of natural log x. It's harder to deal with that. But if you differentiate, you can get rid of that. Okay? So this is a little bit more difficult than the previous problem. I want to express it in the form such as u and the dv. And when I switch it, right, I can du that. So I want u to be natural log of x. Because when I differentiate, I can get rid of natural log first. Then how about dv? Well, I have x there, right? I cannot let v to be x. So dv should be x dx. Okay? Regroup them, right? So what is a v? Gives you x dx. I think you can solve for, if you don't know, you can solve for x in this way. Just put the integral on both sides. Great. Right? So that's going to be half of x squared, right? And plus constant. This side is v. So yeah, you can v is going to be this side is v, right? V plus c1, that's plus c2. You know, both sides are constant different. So essentially, v is half of x. You can let that, yeah. So you can let v to be half of x. All right. So now you have a u and have a u and v. So the integral of x natural log of x dx is going to be, right? It's going to be v times u times v natural log of x times v half of x squared minus half of x squared, and the du is going to be 1 over x dx. That's the du, okay? That's the v. That's uv. Okay. And then no natural log of x there in the integral, and I just only have a half of x dx, right? X squared of x. Then polynomial is easy to evaluate the integral. So what is the antiderivative of x? It's a half of x squared. So, okay. So this is the answer. We can build up a skill, problem solving skill on this type of problems only through practice. Okay? And just like as a job as you're doing, you can learn the theory quickly, but you have to practice. Okay? Okay, sometimes yeah, more exercise, do more, you know, you get more experience. So when you're looking for a job, you know, they always ask, do you have experience? You know, I don't want to train you. and yeah. Right, so let's look at the next problem. Okay, I know how to find how to evaluate this integral, right? No problem. This is going to be e to the x plus c. Okay, how about x times e to the x dx? This is the opposite the way we are not. So e to the x is a very friendly function. Don't worry about that. It's not like a natural log of x. I have to kill it, right? Eliminate it in order to evaluate integral. But here I do the opposite way. I love e to the x. Okay, it's nice when you differentiate. It's still the same function. When you integrate, it's still the same function. It's wonderful. It's the same. Never be changed. Okay, so I love it. So I don't like the x here. Now, compared to e to the x, x is bad. So I'm going to get rid of that. How can I do it? So if this, if you can retain this un, you have to decide which one should be u. Okay, which one should be x. This is a key part. Then uv minus v and du. Okay. The reason I cannot evaluate this integral because there's x there. I want to get rid of that x. Okay, so I have to find, yeah. So this should be my u. That should be my dv. How about this? Then I switch it, right? I keep a v here, but that's good, you know. But du, yeah, this should be the right choice, right? So v dv is going ex dx, and clearly v should be e to the x, right? Yeah, I don't need even to think about it. That's obvious. So u is going to be x, right? If you make such choice, then you can evaluate the integral, okay? So this is a v, you know, this is a u, and that's a dv. So v is going to be e to the x. So uv, u is the x, e to the x, minus v. V is e to the x. What is du? Du is just dx. But I like e to the x. You know, it's okay. The antiderivative will be itself and plus constant. That, right? So it's very important which part you have to, yeah, which part should be u and which part should be dv, right? Okay. So I'm going to ask you to evaluate this one. Please do this part. So similar to the above problem. If it's the integral of sine x only, you know how to evaluate it. Sine x is still pretty friendly function. It's not like a natural log of x. All right, so let's do it. So same idea. I know integral of sine x dx is going to be a negative cosine x plus c. So this is a nice function. You know, it's easy. Okay. So there's x there, addition x there, but that's okay. So we, if I can get rid of x, then I can evaluate integral, right? So this will be u, that will be dv. Then if I switch the order, right, it's u times v minus v times du, it probably is fine. Now, so what is v? Right? So u is going to be x, so then du just dx. And the v, how can I get v? So from here, you already see that, right? dv, this is a dv, right? So the integral of dv is going to be a v. So I think a v should be equal to negative cosine x. You don't need to put a constant here, okay? So that's a v, right? Then a dv is going to be just the sine x dx. Great, okay? So the integral of this sine is going to be u times v, x times negative cosine x minus v, the integral v negative cosine x dx. du is just dx, okay? So the entire derivative of the cosine x is just sine x. Don't forget to put a constant. That's it. All right. Okay. So the next question is, yeah, next question is, what is it? And you know, those are the well-known functions, right? We want to know that what is the integral of natural log of x? What is the integral of arctangent x? Such things like that. Okay. All right. And here's nothing there, just only one function, no choice. Right? If we want to use the integration by parts, there's no choice. This is will be u, that will be the z, right? V is going to be x. Okay, so let's try this. Maybe it works. So it's going to be uv, so x times x minus v du. So x, the derivative of arctangent x. Let's see what's going on. Okay. And the derivative of arctangent x is going to be 1 over x squared and the dx. Okay, the derivative of the function with respect to x will be 1 over 1 plus x squared, and then multiply dx. So you end up with another function, but this function looks better. It's not no tangent and no arctangent there. I think you have to use a substitution, standard substitution to evaluate that integral. So you can let w to be 1 plus x squared. Okay, then dw is going to be 2x dx. Right, so it's going to be x natural log of x minus x times dx is half of dw, and then that's a w in the denominator. Okay, continue. So this is going to be natural log of a absolute w plus constant. The w is always positive, so absolute value itself. Right, so it's going to be so that's it. Yeah, it's pretty strange function, right? The derivative of this function is going to be the arctangent x. Okay. Do problem number 16. Integral of z 10 to the z dz. I think this is similar to the problem x e to the x dx. I remember that. Okay. It's the same type. So we try to get rid of the x over there, right? So that's for the same. So I'm going to express in this form. This is my dv, that's u. Okay. If I'm able to figure out the v, then I can use the integral of parts. So how can I, yeah, u is going to be z, but dv is going to be 10 to the negative z dz, right? Put this both sides, right? So v is going to be, what is the antiderivative of 10 to the negative z? You may forget that, right? Remember, the integral of a to the x is going to be a to the x natural log a. So the antiderivative of a to the x is going to be natural a to the x divided by natural log a. It's going to be like that, right? All right. So clearly, a is going to be 10 to the negative 1. Right? So v should be equal to natural log 10 to the negative 1, 10 to the negative z. Okay? Yeah. 10 to the negative z, come on. This is going to be 10 to the negative 1 times z. A2, right? A is 10 to the negative 1. Right? So that's our v. So now the integral becomes, and the u times v, u times v is z times, okay, minus v times du. U is just z. So natural log 10 dz. Okay? So there's no z in front of 10 to the negative. It's similar to the above problem. So antiderivative, let's see. It's going to be, here's the denominator, it's going to be natural log of 10, 10 to the negative z, and the times z, right? So here, to find the antiderivative, the constant can be taken out. Right? So integral of 10 to the negative z is going to be 10 to the negative z and the natural log of this. And plus constant, right? So this is answer. Okay. Maybe I just still keep it negative, 10 to the negative 1. So this is answer, right? You can simplify a little bit, but that's probably that's enough, yeah. So this is it looks ugly, yeah, because it's 10. It's not an exponent e to the x, 10 to the negative x. But do not always try to use the integration of parts. Okay, it's not, there's so many different type of problems there. When you get a function, you should take a quick look to see what is the best way to solve the problem. Okay, you cannot just apply the integration parts, then it does not work. I know. I remember there was a student when on the test I have 4 problems. Then the student was trying to use the integration of parts for all the problems. But that's not work. Some problems you cannot do that. Sometimes you have to modify the integral first before you apply the integration part. Okay. So take a look at this. Okay. Yeah, you say, I want to try to use the integral parts. And what is u, what is v? Because cosine h log x is a one single function, cannot separate. Right? So you can say, okay, this is my u, this is my v. Let's try it. Okay? Because it's in this section. It's a problem from book. Okay? So it can be u times v. So x cosine nature log x minus v, right? Times du. How can I find a du? Du is going to be cosine becomes negative sign. Right? And then differentiate 1 of x. You get this. Right? Differentiate the nature of x, you get 1 of x. So you will get x cosine nature of x. And x is gone. Right? This is a v du, right? Here's a vu, right? So it's going to be plus integral of sine nature of x. But not too bad. I begin with the cosine and end up with sine. Cosine, sine, the cosine and the sine, they're just twin brothers, okay? Okay, almost the same. So why not I continue? Just work on the integral sine, okay? So integral sine, I do the same. Right. So this time this is a u, that's a v. So it's a u times v minus v times du, right? I'm continue. Okay. So I will get I'll get uv vsx. Let me write in this one. Right? Minus v is x. The derivative u sine becomes cosine. Great. That's 1 of x dx. So this cancels. So you will get negative x sine natural x minus integral of cosine. So it's like a cycle and coming back to cosine. But that's okay. So look at this, right? I think you can determine both. Integral of cosine, natural log x, integral of sine, natural log of x. Why? Well, just look at the above formula, right? And so if you say let a to be integral of cosine, natural log x dx, and b to be integral of sine, natural log x dx, and what do you get? The above formula is cosine is a, right? So a equals x cosine minus plus b. Yeah, plus b. Yeah, plus b. b equals x sine natural log x minus a. And I think you're able to solve it. Okay? And so clearly, a, if you want to find a, I add them together. I get half of x. All right? If I can also get a b if I want. Okay? And don't forget put a constant here. So this is a is the integral of cosine. You can get the integral of sine and solve it for b. Okay? Yeah, it's okay, you know, when it's coming back to the, if you use a integration parts twice, and you get back, right? That's fine. You know, you have twice, then they are different by signs. That's the reason you stay able to solve for the integral. You have to apply the integration parts twice. Okay, let's go back to this problem again. Okay. Is there any other way can solve the problem? Maybe. So cosine natural x, it's composite of two functions. So it's also natural idea to let u to be natural x, right? Okay. So what is du? Du is 1 over x dx. So dx is going to be dx, or okay, dx is going to be x times du. But how can I express x? That is going to be exponential thing, because this is the same as x equals e to the u, right? All right. So the integral times cosine u and e to the u du. All right. It does not look simpler. It does not look simpler. But I have a product of two functions instead of a composite of two functions. Okay. So the question is, how can I evaluate this integral? You have to use this integration of parts again. Why? There's two parts here, right? I have to use the different letters, okay? Otherwise, I'm confused. So I can use the UV and doesn't matter. Let's use the ST, right? DT, okay? So that's going to be ST minus TDS, okay? So what is S? Cosine U. What is DT? E to the, I think a T should be just e to the U, okay? S should be cosine U, okay? So dt is just e to the u du. So I'm going to get cosine u and e to the u minus e to the u, and the d cosine u is going to be negative sine u du. Okay. You still end up with the same cycle, similar cycle. Okay. So you are going to get cosine u e to u plus e to the u sine u du. Okay. Okay. And we do the same. We're going to use same idea. I put sine in front of it. It's EU du. Okay. So this is my S. This is a T dt. And apply the S times T. So T is actually e to the u again. Okay. So sine u e to the u minus TS. So EU. The derivative of sine u is cosine u du. Okay. So we begin with the integral of a cosine u, right? Yeah, integral of a cosine u equals integral cosine u times EU, right? Integral of cosine u EU du equals cosine u e to the u, sine u e to the u, minus e to the u cosine u to u. And clearly, and this is the same, right? Just different by sign. So you move to the right hand side, you get the double of it. So integral of cosine u eu and du equals half of plus constant. Okay, that is the integral. If you don't know the formula at the very beginning, you have to derive it by yourself. All right. So now, oh, that's a very complicated problem, right? So now we have to go back. We change the integral into this, right? So u is going to be natural log x. So cosine natural log x dx is just equal to cosine u du, right? So I think I just needed to put cosine natural log of x, and I have a sine natural log of x, but e to the u is just x, right? Yeah, e to the u is x, right? So you take e to the u out, and that's just x. It's pretty complicated, but it works. You know, you can use substitution or without substitution, just the same. End up with the same result. Yeah, let's take a look at the next one. Natural log of x squared dx. Oops, that's a square, right? We don't like the natural log in the integral. So how do you do that? I just differentiate. At least I get rid of one of it, right? So it's a, this is a my u, that's a v. V is x, right? So uv x natural log of x squared minus x, the derivative of that square, right? I have to differentiate. So get, how can I do that? It's going to be x times 2 natural log of x and the 1 of x dx, right? The derivatives. And you will be surprised this cancels out. So you end up with the integral integral of natural log x, right? We did that before. Okay, let's repeat this again. So this is going to be u, that's a v, right? So u times v, okay, minus x times the derivative of natural log x, just 1 of x dx. Okay. All right, so we're going to get, and plus 2, which is x plus constant. So I got, yeah, so I got, I did not know at the very beginning whether I'm able to evaluate this integral because it's natural log x squared. But there's no other choice for me. I cannot use a substitution. Okay. It's not, yeah, it's not good idea to use substitution here. So I just trying to use just integrate by parts. That's similar to the one I did for natural log x. When I differentiate, at least I know at the head of time, the square will be gone. But then maybe there's still natural log x here. And it surprised to me, x, just natural log x. So that's what we did before, at the very beginning, the first problem we did. So I know how to evaluate the integral of natural log x. Okay? So we already learned how to use the substitutions to evaluate integrals. Now we learn this powerful tool called the integration of a parts. Right? The problem is more methods you're going to learn and more different type of problems you'll be given. So you have to make a wise choice at the very beginning. Okay? The only way you can improve it is to do more exercise, to practice enough so you can memorize the ideas. And so don't use the same method to all the problems. Some of them do not work. Okay, so you have to look at the function and think about whether this is the best choice. Sometimes there will be more than one method you can use, and other method it looks maybe more complicated. Okay. So if you not make the right choice, then it takes much longer time. It's much more, and it's easy to make mistakes too. So my suggestion is whenever you have a time and you do exercise, I hope you can do well in this course. Some students took this course the second time. Okay, for this or that reason did not pass last time, but I hope you take seriously.